Check your understanding. A skydiver opens his parachute, and shortly thereafter, he is moving at constant velocity. What forces are acting on him? His weight acts downwards, and the force of air resistance with the parachute acts upward. B. Which force is bigger? Neither. The forces are equal in magnitude. A 550 kilogram sports car collides with a 2,200 kilogram truck, and during the collision, the net force on each vehicle if the force exerted by the other. If the magnitude of the truck's acceleration is 10 meters per second square, what is the magnitude of the sports car's acceleration? Given mc is equals to 550 kilogram and mt is equals to 2,200 kilogram, and acceleration t is equals to 10 meter per second. Required AC acceleration. Fc is equals to Ft is equals to F is 1. And substitute 1. Mt is and At is equals to MC. AC is equals to AC Mt times 80 over MC. Acceleration is equals to 2,200 kilogram times 10 meter per second squared over 550 kilogram. So acceleration is equals to 40 meter per second squared. Therefore, 40 meter per second squared is the magnitude of the sports car acceleration. Check your understanding. A car has forces acting on it. As shown below, the mass of the car is 1,000 kg. The road is slick, so friction can be ignored. What is the net force of the car? Given F equals 450 N, F2 equals 380 N, and 30 degrees and 10 degrees. Solve for x direction. Fx is equal to 450 sin 30 minus 380 sin 10. If x equals 159 n. Solve for y direction. Fy equals 450 cos 30 plus 380 cos 10. If y equals 764 n. Net force on car is F equals Fxi plus Fyj is F equals 159 Ni plus 764 Nj. What is the acceleration of the car? Solve for x, component of acceleration. Ax equals Fx over m. Substitute. Ax equals 159 over 1000 is equals to Ax equals 0.159 meter per second squared. Then solve for y, component of acceleration. Ay equals Fy over m is substitute Ay equals 764 over 1000. Then the answer is, the result is 0.764 meter per second squared. Net acceleration A equals 0.159 meter per second squared I plus 0.764 meter per second squared. What net external force is exerted on a 1,100 kilogram artillery shell fired from a battleship if the shell is accelerated at 2.40 times 10 to the power of 4 meter per second squared? B. What is the magnitude of the force exerted on the ship by the artillery shell, and why? So, given F equals ma, where F is force exerted on the artillery shell, m is mass of the artillery shell equals 1,100 kilogram. Then A is acceleration of the artillery shell equals 2.40 times 10 to the power of 4 meter per second squared. Putting values in above equation, we get F equals 1,100 kilogram times 2.40 times 10 to the power of 4 meter per second squared is equals to F equals 2.64 times 10 to the power of 7 N. Therefore, the force exerted on the artillery shell is 2.64 times 10 to the power of 7 N. And B, the force exerted on the ship is also 2.64 times 10 to the power of 7 N because it is opposite the shell's direction of motion.